We saw OSPF as a link state routing protocol. We saw this is the protocol that can provide you a complete map of the the enterprises, the network, the topology, and using the SPF algorithm, this routing protocol picks the best path and puts into the routing table all those valuable points we saw. See, every protocol has got a preference value, respect value, trust value. We call that as administrative distance. For OSPF in Cisco, the administrative distance is 110. See, I emphasize on the word Cisco. The reason is this is not a number same for OSPF in every vendor device. In Cisco, this is the preference level. This is the respect level for OSPF. This is not the same level that every vendor treats. Every vendor has got different number. Smaller the number, more preference is given to that routing protocol's route. In Juniper, for OSPF, the preference value is 25. They don't call it as administrative distance, they call it as preference value. It is 25. In Cisco, it is 110. We are focusing on Cisco, so I'm just giving you here that this number is not same for every vendor. Administrative distance for a protocol like RIP, you learned 120. It's not same with every vendor. In Cisco, it is 120. For EIGRP, we learned as 90. But it's not same with every vendor. Again, no vendors have got EIGRP except Cisco. But what I'm trying to say is the number administrative distance is local to the vendor. And we also learned that Cisco OSPF sends hello packet every 10 seconds. These things are same with every vendor, except the administrative distance. All the rest that you learn in OSPF here in Cisco is same with every vendor. For example, the hello packets are sent to a multicast address called 224.0.0.5. And this is sent periodically. How often? Every 10 seconds. If it is LAN environment. If it is a WAN environment, if it is a non-broadcast environment, if it is a WAN environment, the hello packets are sent every 30 seconds. Yep. So these timers are as per the industry standard, not as per the Cisco standard. These timers are same with every vendor. And the dead timer, when hello don't come from a neighbor for 40 seconds, the neighbor is considered as dead. In WAN, it is 120 seconds. So we saw it maintains a table called link state database. But link state database comes after forming neighbor. In order to form neighbor, it is not LSA important. Link state advertisements are not important. In order to form neighbor, LSDB is not important. What comes first is the hello packet, which is one of the packet type in OSPF. You see, first of all, two routers should form neighbor. Only after that they can share the database. So first comes the hello packet, not LSA. Our previous chapter started with link state advertisement. The very first page was teaching us why this protocol is called as link state routing protocol. That is why it started with that link state advertisement. But what comes first is the hello packet. First of all, two routers should form neighbor. After this neighborship, they start sharing the LSAs and LSDBs and so on, which we will be seeing in detail in this chapter. Now, in the first chapter, we have learned about the link state, and now we are learning about the packet types, but you should not take it like this. The sequence in which you have learned is not the sequence in which the OSPF adjacencies are made. That's what I am trying to correct here. The first chapter is talking about LSA. It is not meaning that LSA comes first. It's the hello packet comes first. You see, the very first packet type is hello packet. Hello packets are sent every 10 seconds in the LAN. Now, after forming neighbor, they share their database. The database is shared not in a detailed manner, in a summarized manner. That database, the summarized database, we call here as DVD, database description. You see, every router maintains LSDB. We learned it, LSD, link state database, but they don't share LSDB because LSDB is too big, LSDB is too detailed. It won't share those detailed topology information. Each router shares only summary of it. See, it is not something missing there. Everything is there, but in a summarized manner. The reason why OSPF is designed like that is to reduce the size of update, reduce the size of OSPF update. So the packet type 2 we call here as DBD, database description. Type 3 is LSR, link state request. LSR, link state request. This request is queries. After two routers share DVD, after they share DVD, when they have some queries, they share their queries and wait for the response. The queries that they ask among themselves is what called as LSR, link state request. See, I told you DBD is summary. Because it is not detailed, there may be some doubts for the routers to get clarified. Those doubts are sent as LSR, link state request. And this doubt is received by the neighbor router. A neighbor router sends the clear information as a response to LSR, and we call that as LSU, link state update. So whenever someone sends a DBD, acknowledgement will be sent. Whenever someone sends a request, an acknowledgement is sent saying your request has been received. Whenever an update is sent, an acknowledgement is sent saying thanks for your update. I got your update. So the acknowledgement is always sent as a response for DBD and for LSR and also for LSU. Hello packets are sent every 10 seconds. There is no need for an acknowledgement for hellos because they're going to be repeatedly sent every 10 seconds. If one hello is missing, no problem because the dead timer is 40 seconds. If one hello is missing, that's not going to make any disruptive change. So acknowledgement is sent for DBD, LSR, and LSU. Now, where is this packet types can be seen? Where can we see this packet type? When you receive a packet, how do you know what packet I'm receiving? Is it packet type 1 or 2, which is DBD, or 3, which is LSR, 4, LSU, 5, and acknowledgement? How do we know which one we are receiving? It will be mentioned here. The type will be mentioned here. When you see type as 4 on the received packet, it means what? LSU. Yeah, LSU. And this version number will be 2 if it is IP version 4 OSPF. When we run OSPF for IP, it is version 2. When we run OSPF for IPv6, it is going to be version 3. We are now focusing on version 2. Version 3 is for IPv6. Now, what about the packet length? It depends. Length will vary depending on the type. Hello packet will have few parameters, and DBD will have the detailed, summarized information about the database, links to database. Updates will have small query response. Request will have query. So length of the packet will not be the same. It depends on what they carry. Sometimes they carry a lot of updates, sometimes they carry small updates. So that length will vary. That length will be mentioned here. A router ID for each router. This router ID is going to be unique. Within an area at least, it should be unique. Router ID should be unique for each router. Now that router ID comes with every packet saying this hello is coming from this router. This hello is coming from this router. This DBD is coming from this router. This type 4 update packet is coming from so and so routers. So the DBD or LSR or LSU or hello or acknowledgement, they always come with router ID. That is to tell the receiving router from whom you are receiving this. That is the router ID, which is in the form of 32-bit, like an IP address. It looks in the format of 8.8.8.8 bits, totally 32-bit. And then area ID. This area ID also 32-bit. So if you say area 0, it will take like this only, 0, 0, 0, 0. So if someone is asking you how many areas we can create, the answer need to be 2 to the power of 32, because you got 32-bit for area ID. Okay, so we can have up to 32-bit area ID, 32-bit, up to 32-bit, 0 to 30. Again, checksum values. It is for integrity of the packet. It is to make sure that the packet has not been altered in the path. The checksum is used. You see, OSPF is not a layer 4 protocol. If it is layer 4 TCP protocol, you have the connection oriented approach, but OSPF is an IP protocol. OSPF works in which layer? Works in which layer? Yeah, network layer, IP layer. Yeah. So there is need for some guaranteed delivery, some assurance that the packet has not been altered. That's why the checksum is always sent. Now, the authentication type. OSPF supports both clear text as well as MD5 authentication. EIGRP supports which one? EIGRP supports which authentication type? Only MD5. Only MD5, isn't it? EIGRP supports only MD5 authentication. OSPF supports both clear text as well as MD5. So we here call it as type 0, means no authentication. Let me write as null authentication. Type 1, which is clear text. Type 2 is MD5. This is what you will find here. It will say whether it is T0 or type 1 or type 2. And then authentication string, then the data. Depending on the type of the packet, the data will vary. Hello packets, they don't carry update. Update packet, they don't carry what the hello packets carry. So the data will vary depending on the type. Let me take you to a debug output and show you how the packet looks like. You see, this is how the debug shows. We can see here a OSPF packet is received. It is version 2, meaning IPv4. Type 1, meaning hello packet. Length 48 byte. Router ID, area ID. This is area 1 packet. Packet is coming from a router which is in area 1. Checksum value, authentication type 0, meaning what? No authentication. All right, and it's received on this port. Yeah, this is how a packet will look like. So what I'll do now is I'll take you to the Wireshark and show you the same. We have already these two routers, 1 and 2, running OSPF. And we just started the Wireshark for that. Let me look at this. I'm getting the very first packet coming from router 2. And it is sending the hello packet. Here it is written hello packet to 224.0.0.5. Still the router 1 is not ready. So repeatedly I'm getting hello only from router 2, 10.12.0.2. Let's wait for router 1 also to get ready. Still I'm getting hello only from router 2. And when you click on this, you can see here, it's a version 2 hello packet. You see, type 1. This is what we saw, type 1. And the hello packet looks like this. It has got packet length, the source from where the packet is coming, the area is area 0, checksum value, no authentication, null authentication, so no data. And this hello packet data, it carries the mask, you know, the hello packet will carry the mask, timer, the default priority, the dead timer. There is no DRBDR. We'll talk about those DRBDR stuff later. I'm just showing you how it looks, how the OSPF packet looks. And if you open layer 3 header, you can see here OSPF is layer 3 protocol. And the protocol number is 89. Do you remember the protocol number for EIGRP? EIGRP is IP88, OSPF is IP89, both or layer 3 routing protocol. I think there is some problem with router 1. I'm not getting any hellos from router 1, so let's go to troubleshoot. Router 1, why are you not sending hello packets? So the very first packet is hello. After that, only this DBD, all the stories. Show IP OSPF interface brief. Aha. In this router, OSPF is not running. That is why. Let's do it. Interface loopback 0 IP OSPF 1 area 0. And then I go under interface serial 4/0 enable OSPF. Done. Look at this. Immediately I got neighbor. And now let's go back to Wireshark. You can see here hello packets were sent between both R1 and R2. This is 10.12.01. This is router 2. Now, definitely these two routers should have shared DBD. Let's do one thing. This is hello packet, you see, and this is hello packet, and hello packet is type 1. See, these are all hello packets. I just filtered. In Wireshark, I'm showing only the OSPF hello packets. Yeah, only the OSPF hello packets. Now let us see type 2. What is type 2? DBD. You see, these are all DBD, database description, type 2. So far, I have received these many DBDs from router 1, from router 2, again from router 1, again from router 2, again from router 1. You see in the bracket, it is type 2. And now let's see type 3. What is type 3? Request. Let's see any request has been shared. Yes. Both the routers have sent some LSR. They have shared some LSR. Now let us see type 4. Both the routers have sent some updates twice. Both the routers have sent some update twice. And type 5 acknowledgement. Both the routers have sent the acknowledgements as well. Yeah, type 5, even here you can see. You see, the Wireshark is a wonderful tool. You can easily filter and see. If you don't know how to filter, then you need to keep scrolling up and down and looking for, oh, here is the update. Where is that? Okay, here is the acknowledgement. I want to see a request. Right. Okay, here it is. Well, it's very difficult to see all this. Instead, if I know how to use Wireshark, I can see easily what I want to see. Acknowledgements. Only the hello pages. Yeah. Right. We'll be again and again visiting this Wireshark. As of now, I'll stop here because GNF3.